Review topic 3, looking over accumulating rates of change. And these are usually calculator portion problems. So make sure you have your calculator ready. So the situation is the rate of change of the number of mosquitoes on a tropical island as time T days is modeled by this. And this is mosquitoes per day. So remember, this is a rate of change. There are 1,000 mosquitoes on the tropical island at time 0. That's important to remember. Show that the number of mosquitoes is increasing at time 6. So if we're increasing, then our rate has to be positive. So we need to find R of 6. So we know the rate at time 6. So if you have your calculator and you make sure that you are in radians, so go to mode, make sure you're in radians. We do 5 square root of 6 cosine 6 divided by 5. And we get 4.438. And that number is greater than 0. The number of mosquitoes is increasing. At T equals 6. Is it increasing the whole time? I don't think so. I don't know. But at time 6, it is. The next question. At time T equals 6, that is 6 days in that month, is the number of mosquitoes increasing at an increasing rate, or is it increasing at a decreasing rate? Okay, so we're talking about the rate of something increasing. So the rate of a rate. Well, that would, since R is representing the rate of that rate would be R prime. Now, since this is a calculator problem, we're not expected to have to do this one by hand, even though it would be the product rule. Since this is a calculator portion problem, we can go, whoops, I said second, not alpha. Alpha F2, derivative, with respect to x, of 5 square root of x, cosine x divided by 5. And we're evaluating that when x is 6. And we get negative 1.913. Now this is a negative number, so since R prime at 6 is less than 0, that means the number of mosquitoes is increasing. We know they're increasing, but at a decreasing rate. Are they always on a decreasing rate? I don't know. But it's true at time equals 6. According to the model, how many mosquitoes will be on the island at time equals 31? Okay, so remember that we can find, if we have our rate, we can find the number of mosquitoes that have been added from 0 to 31 by taking the integral from 0 to 31 of R of t dt. is going to give me the total amount of mosquitoes that have been added between 0 and 31. But remember, we started with 1,000 mosquitoes. They were already there. So they don't need to see any more than that. That's fine. So in your calculator, you would do 1,000 plus the integral from 0, to 31 of, and it probably would have been helpful to have saved this function in one of my y equals to save me some time, but I didn't think about it soon enough. Dx. Okay, so 964.335. So we still want to give our first answer to 3 decimal places. But it's talking about the amount of mosquitoes. Can you have 0.3 mosquitoes? I wish. So to the nearest whole number, it would be 964 mosquitoes. And notice they do tell you to make sure you round the answer to the nearest whole number. To the nearest whole number, what is the maximum number of mosquitoes? So remember that the number of mosquitoes in that month are changing. We started with 1,000 mosquitoes, and we ended up with 964. So at some point, we had to have a maximum amount. Now, so a maximum amount would be when that rate equals 0. We've gone from increasing to decreasing. So what we need to do is test some values. So let's see. When is R of t going to equal 0? Well, the first part, well, when t is 0, it's definitely going to do it, right? So this happens when t is 0. And the other times is when cosine of t over 5 is 0, which would be, let's see, well, let's put it in our calculator and find when this function is 0. So I'm probably going to need to change my window because I'm really going between 0 and 31. And I know I got up to 1,000 at least once. I'm going to go like 1,100. Oh, that was way too much. Now let's try 9,000. Oh, I forget that this isn't showing me the number of mosquitoes, and I was kind of thinking it was because I was looking at 1,000. I need to zoom in. Okay, so window, let's go to 10. Oh, that looks a lot better. Okay, so it hits 0 there, and then that point. So I need to figure out those two values of t. So I can go second calculate 0. Where am I at? I wanted to go between there and there, so I need to find my little cursor. There he is. So I need to go between here and there. 7.854. And then 0. Okay, so I'm going to go between here and here. and I get 23.562. Okay, so we really want to figure out what's happening, and we can really use our graph for this. So between time 0 and time 7.854, from here to here, my R is positive. It's above the x-axis. Between 7.854 and 23.562, my graph is below the x-axis, so that's R of t is less than 0. Last section, 23.562 to 31. That's above the x-axis, so R of t is greater than 0. So, the absolute maximum is going to occur when we go from increasing to decreasing. Or at one of our endpoints. So we already know where we're at 0, so we need to test that point at 7.854. So I need to go, okay, so what would we be? 0 to 7.854 R of t dt. Now we already know how many we're at time equals 31 because we found that. And we know how many we had at 0, which was 1,000. So let's find out how many we have here. Now one thing that's nice is in your calculator, if you already had that that integral typed in, and all we wanted to do was change the boundary, I can just go in and go 7.854. And it usually takes a little while in those types of integrals. 1,039.357. Whoops, 1,039.357. So, since R of 0 was 1,000, R of 7.854, I'm sorry, that's not the way I should word it. At time 0, we had 1,000. At time 31, we had 964. So the maximum is 1,039 mosquitoes. All right, the next one. The tide is removing sand from Sandy Point Beach at a rate modeled by this function. So again, this is a rate. A pumping station adds sand to the beach at this rate. Since I have two functions, I might actually put those in my calculator so that I don't have to keep typing them in. So I would probably, on that problem, go in and put in 2 plus 5 sine of fraction 4 pi x over 25, and then put s of t. So I'm going to make myself a note. I did this one in y1 and this one in y2. This one's going to be fraction 15x over 1 plus 3x. Okay, so they're my calculators, so I can keep using those. So, both R of t and S of t have units of cubic yards per hour. T is measured in hours between 0 and 6. Good. At time 0, the beach contains 2,500 cubic yards. That's always good to know is what we're starting with. How much sand will the tide remove during this 6-hour period? So which one is the removal? Oh, that's R. So that would be from 0 to 6, R of T, dt. And that's all you have to actually put on your paper. So we're doing the integral from 0 to 6. I did that one in y1, so alpha f4 dx. 31.816. And make sure you use your units of measure. So that would be cubic yards. You could have also wrote that as yards cubed. That's fine. Write an expression for y of t, which is the total number of yards, cubic yards of sand on the beach at time t. So we're starting with 2,500. And this is how I would do it. I'm removing R of t dt, and I'm adding the sand that's being added. Oh, actually, since this is 0 to t, these should probably be x's. I don't think they came out for that, but and actually on the key they have it combined. 2,500 plus 0 to t. They do s of x, whoops, x, I can't draw an x today, minus what's being removed. Doesn't mean the same thing, so they take it either way. C. Find the rate at which the total amount of sand on the beach is changing at time equals 4. Okay, so y of t is the total amount on the beach. So y prime would be the rate of the total amount. Okay, so if I took the derivative of this, 2,500, well, that just goes away. And if I take the derivative of an integral, I'm going to get my functions back. So that's going to be s of t minus r of t. And if I'm wanting to find out that at time 4, y prime of 4 would be s of 4 minus r of 4. So in my calculator, I would do s was y2 of 4 minus, we did r and y1 of 4. That gives me negative 1.909, sorry, cubic yards per hour. So yards cubed per hour. The next one says between 0 and 6, at what time is the amount of sand on the beach a minimum? Okay, so minimum, that's when y prime equals 0. Let me check it out. Wait, so that would mean when those two are equal. Which, let's see if we can figure that out. Whoops. I'm going to go to my window and change that to 6. Here's the first function. That's r of t. Here's the second one. Ooh! Do you see where they cross? That's where they meet. So I'm going to do the intersection. And it gives me 5.118. Actually, it gives me a really long number. So what I can do is, since I want to plug that in later, is I could save it in A or something like that. And you could actually do it right from here. Since that was the last X value we found, we can pull it up and then store it using the stow button and stow it in A. So from now on, A is that number. So I need to find out at time 0 how much sand we have, and at time A is 5.1178655253. And then I need to also check the other end. Remember, absolute maximum or minimum can occur when the derivative is 0, or it could be one of those endpoints when we're only looking at a certain range. So, at time 0, we know how much sand we had. That was 2,500. At time A, so 2,500, I'll use this version, plus the integral from 0 to A. ST was Y2 minus Y1 dx. So 2492.369. I also need to find out how much sand was there when at time 6. Oh, I'll just go in here and change it. Instead of A, let's make that a 6. $2493.277. Okay, so I've checked my endpoint. I found the point where my derivative is 0. So the minimum, the amount of sand is a minimum when time equals, now we can round it, 5.118 hours. The minimum value is 2,492.369 yards cubed. I'll have the answers to the other problems on my website. And notice how these are all calculator problems as you flip through. So all of the answers to those will be on my website. Now we're going to go to review number 4.